Now it's fine. Audio, I think what is the issue here? Okay. Okay, now I think audio is fine. So let's start with the video. So as I mentioned, we're going to discuss regarding the series and parallel resistor circuits. Okay, let's start with, okay, I have one chart here. Yeah, hi Anjali. So I'm going to discuss series and parallel resistor circuits. Okay, so let's discuss about series resistors first. So first of all, what is a resistor? So resistor is an element in a circuit which resists the flow of current. Okay, or else simply that is a basic definition. Like resistor is an element. Resistor is an element which resists flow of current. Okay, and the basic formula R is equal to rho L by A. I'm not going to cover these questions because it's not related to circuit, but this is a basic definition. The resistance is equal to resistivity into length of the conductor by area of the conductor. And the general another important formula for resistor is Ohm's law, where Ohm's law states that V is equal to IR. Okay, so we are going to use this formula along with few questions, and we'll solve what is the resistance, what is the voltage, and so on. Okay. So let's take a basic example of a series connection. This connection will be like this. Like if one end of the resistor is connected with the first end of another resistor, I can say that both the resistors are in series. Okay, let's suppose this is point A and this is point B. And if I say this is 1 ohm and this is another, suppose 2 ohms, then I can say that these two resistors are in series. Okay, so R effective of this combination, that is RAB, will become R1 plus R2. So this is a basic formula for series connection. So wherever you have two or more resistors in like this, like ending of one resistor is connected with the starting point of another resistor and so on, then those two are, I can say that this is connected in series. And the series formula is simple. Just we need to add all the resistors to get the series formula. So for this, the answer is 1 plus 2, which is 3 ohms. Okay, same way, two important things we need to consider for series resistors is voltage gets divided, whereas current will be same. Okay, so voltage will be get dividing between these two resistors, whereas current will be same across the two resistors. Okay, with respect to questions, you will understand how I am saying why it is dividing and why it is same. Okay, let's see the parallel, what is the basic definition and so on. So parallel, what it should be like, it should be starting points of both the resistors should be connected and ending points of both the resistors should be connected like this. If I say that this is point A and this is point B, and if I say this is R1 and this is R2, then RAB, that is R effective, will be found out by the formula, which is 1 by RAB or R effective is equal to 1 by R1 plus 1 by R2. So this is the formula for parallel. So how to understand whether this is a parallel circuit means the starting points of both the resistors should be connected. I can say this is S is the starting point and this is the ending point, and the ending point of both the resistors should be connected. Understood? Starting points and both the ending points are connected, then I can say that the circuit is parallel. If starting is connected to the ending point of another circuit, this is starting of this one, this is ending of first resistor. If end and start are connected, then it is called a series. If both the started are connected and both the ends are connected, then it is called parallel. And for parallel, voltage will be same. Voltage is same for parallel connections, whereas current is divided. So we can see this is just opposite with respect to the series connection. What I told in series connection, voltage will get divided, current will be same. But in parallel connection, voltage will be same, current will be divided. Okay, so how it is divided I'll show here. If I say this is I, I mean total I, then this will be equal to I1 and this will be equal to plus I2. So I total will be equal to I1 plus I2. What about voltage? Voltage will be same, that is VAB will be equal to VR1 will be equal to VR2. Okay, same way for series, if I want to write, I can say I will write it here. If I suppose this is V1 and this is V2, then total, that is VAB, this will be total voltage. So VAB will be equal to V1 plus V2, whereas what about current? IAB will be same, because in series, as I told, the current will be same. IR1 will be equal to IR2. Okay, voltages will be get divided, currents will be same for series connection. Okay, whereas for parallel, as I told, voltage will be same like this and current will get divided. Okay, now let's see a few questions, then we will understand in detail. So this I got from the previous year questions itself. This is one of the question where they are asking to find the effective resistance across 1, 2, 3, 4. What is the effective resistance? Okay, so if you notice here, what is the connection? This is parallel. So let's find the effective resistance for this circuit. 1 by R effective is equal to 1 by 2 plus 1 by 2. So 1 by R effective will be equal to 1 by 2 plus 1 by 2, nothing but 1. So R effective is equal to 1. For this scenario, same way let's do for this. Here also all three are in parallel, so simple again. 1 by R is equal to 1 by 3 plus 1 by 3 plus 1 by 3. So why I am writing this? Because for parallel circuit, you can see here the formula is 1 by R effective is equal to 1 by R1 plus 1 by R2. Okay. So what is 1 by 3 plus 1 by 3 plus 1 by 3? Which is 3 by 3. 3 by 3 is nothing but 1. So this R is also 1. So what about here? For this circuit, if you see, these two are in series and these two are in series. So whenever you are going to solve this type of multiple resistance circuits, always try to reduce the resistors and then go for the other step. Okay. So here it will be, I can say first two are in series. So it will be 4 plus 2, which is 6. And here it will be 3 plus 3, which is also 6. So two 6 ohms are in parallel now. So now I can say 1 by R is equal to 1 by 6 plus 1 by 6. So 1 by R will become 2 by 6. 2 by 6 is nothing but 1 by 3. Therefore R is equal to 3 ohms for third circuit. Okay, same way for fourth one, you can say this is easy. These two are in parallel. So 1 by R is equal to 1 by 1.5, sorry 0.5 plus 1 by 0.5, which is nothing but 2 by 0.5, which is 4 times. So R is equal to 1 by 4 for the fourth scenario. So for this question, I think they have asked which circuit will give you 1 ohm. So the answer should be 1 and 2. Okay, hope you understood. So let's go to the next one. Okay, this is very interesting question. Here they are asking to find the effective resistance between X and Y. Okay, so if you notice this point, that is A, if I mark, and this point if I mark it as B, then it is simply, I can say that we have, if you notice, if you notice this point and this point are same, that is X point is equal to B point. Same way, this point A is connected to Y here. So A point and Y point are equal. So to find the effective resistance, what I will write is, I will write only 2 points, which are X and Y. Why? Because X, B is equal to X and A is equal to Y. So simply if I write X and Y and write all the 3 resistors, then I can easily solve this question. So let's see first resistance. It is between X and A. So X and A is nothing but X and Y. So you have one resistance which is 2 ohms. Then you have another resistance which is A to B. A to B is nothing but X to Y again. So again this is 3 ohms. And you have one more which is B to Y. B to Y is nothing but, again I can say it is X to Y only, which is 6 ohms. So now I can say all 3 resistors are in parallel. So simply 1 by R is equal to 1 by 2 plus 1 by 3 plus 1 by 6. LCM is 6 here. So 2 3s are 6, 3 2s are 6, 6 1s are 6. So it is 6 by 6, which is 1. So 1 by R is 1. So R is equal to 1 ohm. Okay, understood. So let's move to the next question. Okay, this is also R effective question. So here also what I will do is, first I will solve the inner part. Inner part means these two are in series, then to this parallel, and then these two are in series. So this circuit I will first draw it as 10 ohms, and then this is 20. 10 and 10 in series, this becomes 20, and then this we have 20 here, and so on. Then again this is 10. So 20 20 are in parallel, that is 1 by R is equal to 1 by 20 plus 1 by 20, so which is nothing but 2 by 20. 2 by 20 is 1 by 10, so R will be equal to 10. So this becomes effective as 10, and again this is 20. So all three together in series. So it is simple, 10 plus 10 plus 20, which is 40 ohms. Hope you are able to answer this question. Let's move to the another one. Okay, so this is the final question for today, where I am going to cover the series, parallel combination, where total I will be equal to I1 plus I2 plus I3. I am going to prove this here. Okay, so let's solve I1 first, because the Ohm's law you have to use is here, which is V is equal to IR. So if you consider R1, so V, as I told you, for parallel connection, what is the parallel connection? I told you first point, parallel connection voltages will be equal. For parallel, voltages are equal, that is VAB equal to VR1 equal to VR2. Okay, so same combination I'm using to going to use it here. V is equal to IR, where this voltage, that is 12 volts, will be present at this point, and this point. Okay, so V1 is equal to I1 R1, that is I1 R1. V is nothing but 12 volts, as I told you here. So 12 volts is equal to I is, we need to find it here, and R1 is 5. So I1 I can say which is 12 by 5. Same way let's find for I2 and I3. V2 again will be 12 here, I2 into 10 ohms. So I2 is equal to 12 by 10 ampere. What about third case? Again 12 is equal to I3 into 30. So I3 is equal to 12 by 30. So we have three currents, which is I1, I2 and I3. So let's find R effective and then find I value. Then we have to compare and confirm whether I is equal to I1 plus I2 plus I3 or not. Okay, so let's find R effective. R effective is about parallel combination of three resistors. So R effective, that is 1 by R, is equal to, what are the three resistors? 5, 10 and 30. So it will be 1 by 5 plus 1 by 10 plus 1 by 30. LCM is 30 again. So 5 6 are 30, 10 3s are 30, 31s are 30. So this becomes 10 by 30. So R I can say it is 3 ohms. R effective is 3 ohms. Voltage is how much? 1 by 5. Okay, voltage is 12 volts. Okay, so 12 volts is equal to 3 into I. So total I effective should be equal to 4 amperes. Now we need to just check and add I1 plus I2 plus I3. I should get as 4 amperes. Let's check it here. I1 is 12 by 5. 12 by 5 is nothing but 5 2s are 10, 5 4s are 20. This is 2.4 amperes. This is 1.2 amperes. What about here? 3 4s are 12, 3 10s are 30. So this is nothing but 0.4 amperes. So if I add all three, 1.2, 2.4 and 0.4, I1 plus I2 plus I3. If I add all three, I1 is how much? 2.4, 1.2, 0.4. 2.4, 1.2 and 0.4. If you see here, if I add all three also, I'll get the same value, which is 4 amperes. Okay, so simply I can say that if in a parallel circuit, if a current is coming like this, then this current will be get divided into all three circuits, and I total should be equal to I1 plus I2 plus I3. Okay, so now you think everyone understood how in parallel circuit current gets divided, because this current will be get divided into 3 based upon the resistance which is have. Okay, so if you have any doubt in this video, please do comment so that I can check and respond to you accordingly, or else if any specific question if you want for any solution, you can directly mention in the comment section so that I can check and prepare another video where I will explain in detail for that respective question. Okay. Thanks for watching. So for these type of videos, please do subscribe so that you can get and enable notification for another videos.